So welcome everyone. So we closed the second day of the conference with Eamon O'Reilly, who celebrates his debut as a speaker at Integrate. So Eamon is a principal program manager for Azure Functions, and today he'll be explaining event-driven computer patterns and informs us about the roadmap for Azure Functions. So once again, please join me in welcoming Eamon.
Perfect, sir. Yeah, thanks a lot, everyone. I really appreciate you guys hanging around until the end of the session or the day to look at Azure Functions and kind of talk about what we're doing with Azure Functions, some of the event-driven compute patterns you might be thinking about as you're doing your integration, and also kind of touch on some of the new things that just got announced and give you a couple of demos along the way so that hopefully you guys can try it out for yourselves as well. I will answer questions at the end. So if you have any questions, please put them in the Q&A, and then I'll have a look at the and hopefully answer some of those. So kind of those four areas I'm going to talk about today. One is just kind of a high level about, how do you build apps in Azure to kind of give you the different capabilities. A lot of you guys might be familiar with these, but I want to give an overview of, what is capable, and then you kind of have an understanding of where functions and some of the serverless capabilities fit in the overall Azure ecosystem. The other area then I'll go into is kind of all the different capabilities we have in Azure Functions. When you try and think about, what kind of patterns are you trying to solve? What are the use cases in your organization? Where would serverless fit in, and where would Azure Functions? Hopefully, you get a good understanding of the different scenarios that we enable with the event-based architecture. And then I'm going to spend a little bit of time talking about functions that run anywhere. And then give a little bit of brief view into some of the stuff that was recently announced and some of the things we're working on as we go forward. So when you think about Azure, we really try to kind of give you all of the breadth of capabilities as a developer or as IT when you're trying to manage your applications inside your organization, whether this is building new applications that are completely native on Azure or moving some of your applications over. The overall goal is to kind of give you that whole flexibility control you might need from the lower level capabilities of using virtual machines and networking, all the way up to the developer productivity services we have with Azure Functions, Logic Apps, Service Bus, Event Grid, and then all of our data services as well. And then one of the main things we try to spend a lot of time, not just in Azure Functions and across all of our PaaS services, but across Azure in general, is trying to make it very easy for developers to use the applications or to develop the applications using our built-in IDE support, either using VS Code, Visual Studio, but you might even be using third-party IDEs, and we have native integration with those as well. And then the other part of that is making sure we have a seamless DevOps scenario so that you can not only develop your applications locally, test them locally using inner loop development, but then as you start to go to outer loop, how do you make it very seamless to deploy your applications onto Azure, either if it's functions or any other services, kind of in a unified way. And then the last thing is, how do you apply management? So a lot of the challenges in the past were there was a lot of procedures built in on how to ensure that your infrastructure and applications were locked down. When they were running on premises, how do you use similar types of things where you can apply your own governance and policies on top of these applications as they roll out into Azure? And that comes up a lot when you're using serverless solutions, because we've kind of taken away the responsibility of the infrastructure, but there's still a lot of policies and governance that organizations need as they apply those two applications running in Azure. So the overall goal with serverless in general is to kind of move the capabilities to the right. So the further you go from on-premises to IaaS, to PaaS, and then eventually to SaaS, obviously there's less responsibility for the customer. So you guys don't have to do as much, your IT departments don't have to do as much, because a lot of that is handled by Azure as you start to take advantage of our PaaS and even SaaS services. But with that, you lose some of the control that you might need from a governance standpoint. You might have a lot of policies built in on how your data or how your network is required, or security. And so you have to find that kind of right balance between what your applications are trying to accomplish and the requirements of your organization. And so that's why we've tried to give you a breadth of capabilities across both of these spectrums. So one of the goals of Azure is to try to make basically a platform for building all kinds of applications. And so this usually comes down to, do you need more control over the infrastructure that those applications are running on, or can you move that responsibility into Azure and into Microsoft and focus more on the application side? And so there's this balance between I want to build my applications using Kubernetes, which is growing really quickly across Azure, across all organizations, most companies we're looking at. It is definitely one of the fastest growing services we have. And I think that's because it gives you that nice flexibility where you still have control over the infrastructure, but at the same time, it kind of gives you this orchestration layer on top, which makes it easier to build microservices using containers. But obviously, as your productivity requirements go up and you have less need to control the infrastructure and manage it, then you can start taking advantage of our PaaS services like web apps. And then further on, where you saw a lot of sessions around logic apps, and I'm going to talk about functions today and some of its capabilities. But I think this is something to keep in mind as you are trying to build applications, is that there's a spectrum of capabilities in Azure that you might want to take advantage of, different ones for different needs inside your organization. So it's good to have a familiarity with the different services we have, and then how you want to build your applications, taking advantage of each type of service offered. So I'll spend a couple of minutes just talking about Azure Functions and kind of all the different use case and capabilities we have, just as a primer for those who may not be as familiar with it. And then we'll dive into some of the new things we're announcing and give a couple of demos. So when you think about, what is serverless? The overall goal of serverless, I mean, it's somewhat defined in the name, which is to try to abstract away the server so that you or your organization don't have to manage them anymore. And the overall goal is that you're just focused on the developer productivity, focus on your code, and not have to worry about how the underlying things are happening. The other thing that's serverless is kind of this new event-based architecture. And so traditionally, you would build applications maybe as 3-tier applications where the front end's calling the back end is calling, or the middle tier is calling some back end, and you're doing some processing, and it's kind of linear in how the calls are being made. But event-based architecture allows you to scale out a lot more by using things like event hubs or service bus, so that you basically can push messages there, and then the compute that processes those can scale automatically, is basically how Azure Functions works. And then the last big benefit of serverless, obviously, is you only pay for what you use. And so you don't have to kind of be always worried about, well, if my app spikes, do I have enough infrastructure? Do I now have to pay a lot more for that? It just scales up and you only pay for when you're using it, and then it scales down again when you're not using the compute. So that's kind of what it is. But some of the benefits I mentioned before is the ultimate goal of functions is and logic apps and all of our kind of PaaS services to some extent is to allow you to focus more on the business problem you're trying to solve and less about the management. I know when I worked a lot, I used to work in System Center, and it took a lot of time working with the developer teams and the ops teams to try to understand what the application can do. Do we have the right infrastructure in place? How are we going to manage that? What are your scale and performance requirements? And so the developer not just spent time trying to solve the business problem, but they also spent a lot of time trying to work and understand how the application was going to be managed and run by their operations teams or themselves. And then the other key benefit is efficiency. So one of the things about serverless is that because you're only focused on the business logic, you can actually get your applications out a lot faster. And so you reduce that overall timeline when you're trying to build applications, because now you can take advantage of these PaaS services and let the infrastructure be managed by Azure. And then one of the last things is flexibility. And so this, again, is because we've tried to simplify the programming model, it allows you to get started very quickly. You really just have to write that business code to process messages and hand those off to the next downstream service. So it kind of allows you to give this microservice architecture where you're only focused on specific tasks using Azure Functions as your serverless layer. So what does the programming model look like? When you think about where we're at, integrate, and really Azure Functions is very designed around a very similar goal of how do you integrate different systems together so that you can, process some work and then hand some more work down to down-level systems and let them do some extra work that might be needed on that. And so how that works in Azure Functions from a programming model is that we basically set up events that are being sent to maybe service bus, event hubs, Azure storage queues, anywhere that basically messages or data that needs to be processed are being sent by some other system. And so once those events show up in those systems, Azure Function then responds to those. And so this gives you the ability to write code in your own preference of languages to kind of respond to that event and pass it on to the next system behind that. And so you can use any popular .NET languages like F# or C#, but also you can use other languages like Node, Java, PowerShell, or Python. And then obviously when you process that data, you have to send it off somewhere else typically. And so you can send this off to these down-level systems in a very similar way that you configured how the events were showing up. So the program model is designed to be as simple as possible. So the ultimate goal with a lot of our integration with our triggers and bindings is that you can declare how you want to react to events that happen in third-party systems and what systems you want to send to. So those are used using declarative mechanisms. So here you can see we're looking for an item on a queue, and then we want to be able to send it after we processed it to another queue after the changes have been made. And so your business logic really is saying, okay, I'm going to get a message, I'm going to do some work on it, and I'm going to send it to another queue to be processed further down. And so it allows you basically to only write the code you need to do on that message and not worry about how to integrate and manage all the connections to those systems. So you can see in the function.json, which is the file, you can see exactly how things are defined and how you can integrate into those Azure queues. But it works very similar if you're working against Service Bus or Event Hubs or Event Grid or any other system that you might be looking for events. So patterns for functions, there's a whole set of them here where you're doing real-time file processing, machine learning processing, web application backends, if you're doing IoT connected backends, long-running orchestrations, and event-based automation. So kind of any time that there's a good use case where you need to basically process some events that are happening, functions is a real good candidate to look at and say, you know, can I take advantage of serverless, that on-demand scale, the connections we have with our programming model to go and work against and solve that solution. One of the things we introduced about a couple of years ago, and we've been kind of working more and more over the last year, is our premium plan. And the idea behind the premium plan is to really try to solve a set of scenarios where customers needed extra capabilities that were very difficult to provide in a purely serverless manner, where we have very prescriptive size of memory and compute. And so with premium now, you can pick what kind of compute you might want to use, what kind of memory you might want to use when you're processing those functions. So it's opened up a whole set of scenarios that are very difficult to implement when you had constrained environments. The other thing the premium plan tried to solve was the cold start problem. As most of you guys know, if you're writing APIs and they're backed by functions, then if you need those APIs to respond real quickly, then you had a challenge with cold start because they may not be available at the time, and so you'd have that small second or two delay when your APIs are first responding. But with premium, you can actually allocate an instance, so that's always available, and so it increases the response time. The other area is VNet connectivity. So this is an area we've been working on over the last year. And our ultimate goal, I think we've kind of hit it now, where you can lock down your function apps completely from the outside world. And you have control if you want them to be opened up as HTTP, and they go through that VNet scenario. So it kind of gives you basically ingress and egress management capabilities on top of your function apps. And then a couple of other things that are part of the premium plan is you can now run up to 60 minutes. Which is a lot longer than you would get in the consumption. So there might be some workloads that require that, as well as you can kind of define the size of your premium plan so that you can ensure that only a certain amount is going to be spent. So I talked a little bit about some of the premium plan scenarios, but here's a few that we've seen customers using over the last year or two. Premium is kind of becoming very popular, especially in enterprises where they need a lot more control over their networking. But they also have very specific scenarios like compute intensive, single-threaded jobs, latency I talked about, sensitive APIs. And also, if you require that complete network isolation, you can now do that using Azure Functions with the premium plan. So the other area, some of you might be familiar with, but it is a big investment for us, is durable functions. And what this allows you to do is to write orchestrations of multiple things, have them long running, but also have state. So when you think about serverless, it doesn't really have state. That's one of the ideas behind it, is that you just process things, send them on to the next down-level service and let it get processed again. But sometimes you have these long-running orchestrations, and you need to have some state as part of those. And so Durable tries to solve that problem in a code-first way by allowing you to write code that basically does orchestrations for you. And here's some of the common scenarios that you will see. So if you want to do function chaining, async HTTP APIs, fan out, fan in, long-running monitor, human interaction, or even event aggregation. There's a whole set of scenarios that are well documented that if you try to do these using Azure Functions in a purely serverless way without Durable, it would require a lot of code for you to write, but also you'd have to have some external system to manage the state for you. And so with Durable, all of that is taken care of natively. The other area we've seen kind of a huge amount of growth in over the last couple of years, which is one of the areas we continue to focus on, is enabling you to use Azure Functions to do event-based automation. And so a lot of our customers are trying to take advantage of automating the complete, DevOps lifecycle, but as well as IT management tasks that might be happening throughout the system. And so one of the things that often happens is because things are scaling very quickly inside of these cloud services like Azure, that is not as well defined up front on how you need to respond to events that happen. You might be getting alerts that are coming through that you need to respond to. And so all of those things can now be done using event-based architecture as well with Azure Functions. And this was basically opened up to a lot of IT people to write solutions, but also developers who are trying to solve it, but not having to write all the code in .NET, which is one of the reasons we added PowerShell and Python into the supported languages as well to try to solve these automation scenarios. And so when you think about doing any automation specific scenarios that you want to integrate across multiple different systems, there's a whole set of automation capabilities in Azure, but with the functions, we've kind of introduced this event-based automation as well, so that you can respond to events that are happening in the system that aren't known upfront. So when we think about these automation trends, basically the main goal of introducing Azure Functions is really try to bring the operations and developer teams a lot closer together, because as you're writing these applications, and one of the goals with functions and serverless in general is to increase the productivity and delivery of your solutions automatically. And so that requires kind of a DevOps model to really accomplish that. And so you end up with IT, SREs, developers working very closely together. And they have to kind of share the responsibility across dev and IT teams. And so having a common language to enforce those requirements is something we've been trying to solve with Azure Functions. And Logic Apps as well plays kind of a key role inside of this. From the tooling perspective, one of the reasons Azure Functions can be attractive is that you have common tooling between development teams and operations teams, but they use their own languages of choice. And so often developers may be writing things in Node or .NET, or maybe even Python, but then the operations teams want to be able to use more scripting-based languages like PowerShell and maybe Python, but all of the common platform is standardized between those two different teams. So here's some of the patterns we've been seeing with event-based automation. And PowerShell, I think, since we introduced it, is probably one of the fastest growing languages we have inside this service. Because we have more and more developers, but also IT trying to solve these types of challenges that are difficult today using their existing automation solutions, like responding to events on resources, like a storage account was created, I need to go do some action, a virtual machine was created or a container, how do I actually go and respond to that? So all of these kind of maintenance tasks as well as automation tasks are now available using event-based automation patterns using Azure Functions. So here's some of the scenarios I talk about we've seen customers doing that you might be able to use yourself. Like a VM is deleted, remove it from the monitoring system. When a resource group is created, look up the cost center for the region, add a tag with the number, add AD groups to SQL or manage AD itself. All these kind of capabilities are available when actions happen on side of your resources, but then you also want to operate those resources as they expand or problems come up with alerts. You can respond through event-based automation as well. Okay, so with that, that's kind of just a high-level walkthrough of Azure Functions, kind of the core scenarios we see being used inside of Azure, as well as where some of our investments have been over the last year, but also where they'll continue over the next, just kind of really round out and make all those scenarios available to you and to customers trying to take advantage of event-based architectures. So with that, one of the things we just announced was general availability of PowerShell for Durable. So I wanted to show a quick demo of that, give you guys some visibility into how you could use it, but it's a very similar way if you're using any other languages. We just released Python Durable support a couple of months ago, and we've had it for others for the last few years. So with that, let me jump into the portal. And I'll basically show you just an application function app and how you can use Durable to kind of automate tasks inside of the Azure environment. So here you can see it's a standard function app. If I go into configuration, you can see that it's running PowerShell. And you can see here it's running PowerShell Core with PowerShell 7. And the other thing I took advantage of was identity. So if you guys aren't familiar, we added support for managed identity during the year, but the managed identity kind of solves multiple purposes. One, it gives your function app its own identity, so it can now access other resources. And so once you enable that, I went to add role assignments, and you'll see that I actually granted this function app access as a contributor on my subscription. And so what this allows this function app to do now is to take actions across my subscription when events happen inside the system. This could be monitoring events, could be access to any resources that are needed inside of there. The other thing I'll mention related to identity is that we also brought in managed identity so that you could access like secrets inside a key vault without using any connection string. So if you have secrets stored in key vault, you want to be able to retrieve them, you can now grant your function app the identity access to those key vault secrets, and they can pull them down at runtime, and nobody else has access beyond the function app. So when this function app gets deleted, so does the identity associated with it. And the other thing we've done with identity recently is we've added preview support. So now when you're connecting to other systems like Service Bus or queues or event hubs, you basically can use identity to access those. So the managed identity available here can also be granted access to those other services so that you don't have to put your secrets inside the connection strings when you're trying to pull messages or events off those systems. Okay, so I have a function app, just a standard function app, and then I'm going to go and deploy a durable PowerShell to it to let you guys see how that would work. So if I come in here, you can see that I have this Integrate 2021 function app, and I'm going to publish a durable function to there. And when you think about durable really contains, it has three capabilities associated with durable. So there's three kind of functions you want to write. One is the client function. So this is going to kick off the orchestration. And so I've created one as a HTTP trigger here that I can call directly. But this might be a scheduled task that you want to run, on a certain timer and then trigger off the orchestration. Any kind of those clients, whatever you decide, can be your client to kick off the orchestration. Once that orchestration is kicked off, this code will get run. And so my scenario here, what I'm doing is I'm actually going to shut down any virtual machines in my test subscription that are running so that they're not using compute when they're not needed. So oftentimes in like test subscriptions or even in certain other environments, you might want to make sure that you have some policy that says, active VMs after 8 o'clock need to be shut down unless somebody has opted out of it. And so here you can see I'm just getting a list of all the running virtual machines in the environment. And then I'm going to use the capabilities of Durable to kick off basically shutting down those machines in parallel. And so the nice capability of this is there's some built-in constructs in Durable allow you to do things in parallel, like one of those scenarios I mentioned earlier. And so what this one does is it calls another function called VM shutdown to actually go and shut down the machine. And so the last one you'll see here is shutting down the machine. So for this one, I just wrote out the resource group and name. If I uncommented this, it would actually go and shut down those machines automatically for me. And so those are kind of the three main concepts you have to have when you're doing durable. One is, how is the orchestration going to get kicked off? So is there a client that's going to be created to kick off the orchestration? And then here's the orchestration, and then the activities the orchestration is going to call is VM shutdown, or for whatever scenario you're trying to solve. And the one thing I'll mention inside of here, identity that I created, you can see here that if identity is enabled, I can check this environment variable at runtime, then it'll automatically connect AZ with using that identity, so I can manage those resources automatically. And so that gives me that permission to call into Azure, retrieve the list of VMs, but also shut them down. So once that's available, you can then just publish these directly into the portal. So I'll hit deploy. And all of that durable code now is getting deployed up into the portal. Again, one of the advantages of using functions and durable, and you saw earlier with logic apps, is that you can do all of your development locally. You can do all of your inner loop debugging locally, so that you know your business logic is correct, your application is good, and then you have the option of how you want to deploy it. Maybe it's a test environment, just going to deploy directly from the VS Code into your test environment to make sure it works when it's running in Azure, or you can actually decide to go through GitHub or Azure DevOps or your own deployment pipelines and have all the policies applied at that state as well. So there it got deployed. And then I'll go back into the portal. And hopefully if I go into functions, you can now see that those three functions are available. So I have the client that's going to start it. I have the orchestration that's going to get the list of VMs, and then on each, the orchestration is going to call VM shutdown in parallel, and then it'll aggregate the results together and run and be able to show if everything worked correctly. So the nice thing about this is you can just go in and you can see the code just like you would locally inside the portal as well. You can get the function URL. And I could kick this off and run it directly from the browser, or I could run it from a third-party system, maybe a different external system that you want to call. You can expose this as an API, and this allows you basically to have that whatever client functionality you need to kick off the orchestration using durable. Okay, so with that, I'm going to stop, and I'll continue with the deck. So hopefully I kind of showed you a bunch of different scenarios for durable. Obviously, this is available in all languages now, from Python to Node to .NET, PowerShell. We just announced, so which is why I wanted to show you guys. But there's lots of scenarios there where you think serverless might be very difficult to implement. Then you may want, and you require some state or some orchestration, and you want to write code. Then durable is a good candidate. Okay, so I'm now going to move into functions that run anywhere. So as you guys know, over the last couple of years, well, since we launched Azure Functions, we've always been an open source project. And what this allows is for the community to get a lot more involved in how we build Azure Functions, not just for the runtime, but for the extensions as well. So this allows you all of those triggers and bindings to provide feedback, but suggest other ones. And our goal really is to try to build functions in an open source nature, so that as new ideas come from the community, if people have questions, they can go into GitHub, ask questions, and allow us to kind of engage in that community way. And that's been very popular since we first launched, and it's one of the kind of goals we've had with functions, is to always engage customers and the community. So if you want to go and learn more about Azure Functions, it's all available up on GitHub as well. But one of the things we've also introduced working with Red Hat is Kubernetes-based event-driven autoscaling, or KEDA. And what KEDA allows you to do is to basically all of that scaling capabilities we have inside of Azure to be able to use in your own environments as well. So if you have a Kubernetes environment, you've basically taken the functions runtime, and you want to be able to do your own serverless environment and build everything out yourself on a Kubernetes environment, you could take Kada and get very similar capabilities that we provide in Azure in your own local environment. And so that was one of the goals of releasing Kada to the community and making it available for you guys to use in your own environments. But the other thing about Kada was we wanted to not just have the ability for you and for customers to kind of build out their own platform by taking the functions runtime, taking Kada and taking Kubernetes and stitching all together and building out your own application platform. But we really wanted to think about how do we make all of our Azure application services available wherever you want to run them. So today, before build, we only allowed you to run our application services either in Azure or with functions, you could run them in your own environment. But at build just last week, we announced that we now have support for Azure application services with Arc. And I think you probably saw through some of the previous sessions with Event Grid, with Logic Apps, with APIM, where those are now available with Azure Arc. But Functions is also available. So you don't have to kind of stitch it all together and build it yourself. You have that nice consistency management plane when running with Arc as well. So the Azure Application Services, the goal really is to run your apps anywhere. And this kind of opens up a whole set of scenarios that we've heard feedback from customers where a lot of they like the productivity that we give them inside of Azure. So you can take advantage of all our PaaS services. You can, get quick to market, all the benefits of focusing on the business logic, but it only works if you're hosted in Azure. And we have a ton of workloads that still need to be on premises, or we need more control over the infrastructure, so we need Kubernetes. And so we took all that feedback, we tried to say, how can we solve that and give customers the flexibility to build their applications using the best in breed PaaS services, but be able to have the control over the infrastructure and run it anywhere they want. And so that was kind of the main goal of accelerating the development, but also offering this productivity with Azure Arc. Okay, so with that, I'm going to jump back in and give a quick demo of Azure Arc with Functions. You may have seen some of these earlier with Event Grid or APIM or Logic Apps. I wanted to make sure you kind of saw the full picture even with Functions as well, and allow you to kind of get up and started quickly if you want to take advantage of hosting Azure Functions anywhere you want, but get all of the benefits of a consistent management plane and developer experience. Okay, so I'm going to go back into the portal. And if I go back here, I'm just going to go and create a function app. So I'll pick my Integrate 2021 resource group, and I'll give it the name Integrate 2021 Arc demo. That's available, and then I'll pick a runtime stack. So again, the exact same developer experience that we offer. If you're running in Azure, you can pick whichever one you like. So you could pick Python, you could pick a different version if that's the one you're needed. But the key difference with Arc is now the same developer experience you have when you're building on top of Azure is now available when it's actually running in your own on-premises environment or even in a Kubernetes environment hosted in Azure like AKS. So what you'll notice here is all the traditional regions that you could pick normally to host this application. There's now new ones called custom locations. And these are ones that your organization has built that allows you to host this function app. So I'll pick Northwest Farms. I could pick a storage account, create a new one. I'll just go through some of the defaults here. Yes, we can use application insights like we would in Azure. So nothing has changed in how you would normally create a function app. And obviously I'm showing you through the portal, but the same capabilities are available if you're using VS Code, if you're using Visual Studio, third-party IDEs. One of the things about going with Arc is that you get that same developer and management experience, no matter where it's being hosted. So I can go to the resource. And now you can see that it's been hosted on Northwest Farms. And it's actually been hosted on a Kubernetes environment. It's not being hosted inside of Azure. So I can click in, and yes, my Functions 3.0 app is up and running. And so nothing really changes from the developer experience, but now you have control over where you want to get hosted. So if your organization has these policies or governance about certain apps have to run locally, and I need this, my data always to be on premises, you can still provide that now, have the functions process that data locally by deploying them onto this Kubernetes environment, either on your on-premises, third-party clouds, or even in AKS. And again, all the similar capabilities you would have inside of Azure are also available running on Kubernetes. So the last thing I wanted to touch on real quickly was go back to the, actually I can show you, I think you've seen this before, but I'll just show you real quick how these resources are created. So again, for this demo, I used AKS as my target environment, but this could be any Kubernetes cluster that's on premises or third-party clouds. The key thing you have to do is you have to register with Azure Arc. So you can see this Kubernetes environment has been projected into Azure Arc so that we can manage it. And if I go into the extensions, this is where you can add the capabilities inside of here. Oh, let me just go back to when I had created that. Works. So there you can see it's installed and running. That's where I deployed that function app. But I could also go and add other application services onto that Kubernetes environment inside of here. So that API gateway, you probably saw with API management demos, but also event grid. And so I can get logic apps, functions, web apps, event grid, and API management onto that Kubernetes environment. But once it's been installed by the operators, it kind of they make sure the environment meets the requirements you have from a control and governance perspective. The developers in your organization now don't have to learn a new set of tooling. They don't have to figure out how do I, build on Kubernetes? Do I need to understand all these Docker files, the YAML files, all the container stuff? They can use those if they want to on top of Kubernetes, but they can also take advantage of these native PaaS capabilities. But the difference you'll notice is that everything is managed in a consistent way. So the function apps running on Kubernetes are in the same view as the function apps running in Azure. I can manage them. I can apply policies at the same way. I can apply role-based access control to these. And all the developer and deployment experiences also stay the same. And so it kind of opens up this whole set of capabilities that before you would have to learn 2 different ways of building applications depending on what your target host was. Now you can just use the one standardized development and deployment processes to build applications no matter where they're hosted. Okay, so the last couple of minutes I'll just spend on the functions roadmap. Hopefully you saw a lot of the capabilities we introduced there. One thing I'll mention with the functions that run anywhere with Azure Arc is that not just do the functions capabilities, but even durable is also available there. And the reason durable is working inside of Kubernetes is that we just announced support for using SQL as your storage provider for your durable functions, or you can use a new capability that's backed by event hubs if you're running in Azure that you need additional scale with. And so this allows that portability of not just standard Azure functions, but Azure durable functions as well onto Azure Arc. And so hopefully you can start taking advantage of that as well as it just came out. So when you think about what we're trying to do with Azure Functions is we're really trying to give full integration across the Azure ecosystem. And so no matter what kind of scenario you're trying to build, one of the things we're trying to make sure with Azure Functions is that we have this integration into all these different systems so that as the data and messages need to be processed, you can plug in Azure Functions very seamlessly to process that data, but then also send it on to other systems that need to store or do additional processing on side of that. And so that's one of the core capabilities of Azure Functions is to integrate across all of the different services in Azure and make it seamless for you to build any kind of application. I mean, the one thing you have to always think about Azure Functions is it is a new way of doing event-based architecture. And so you gain all of the reliability, scalability, efficiencies of doing that, but you do have to think about how you're going to organize your application, your code to take advantage of that. So from the roadmap perspective, there's a lot of capabilities that we just announced. I only brought in a few here because we're constantly improving languages support, performance, and scale. But since we just launched Azure Arc, that's kind of one of our major focuses over the next few months is to bring that to general availability, because it is currently only in public preview. So it will take us time and kind of process all the feedback from you and other organizations. I mentioned the storage providers real quick. You can learn more about those at our documentation on how you can take advantage of SQL if you're running on premises, or even in Azure, or the new Event Hubs backed provider if you're trying to do some really fast scaling that might require it. And then the other thing I wanted to mention is that you may have seen in some of the other sessions, we've introduced this concept of kind of sample templates, so that your inner loop and outer loop experience when you're building your applications, no matter if it's functions or logic apps or event or APIM, have a standard way for you to take advantage of that using GitHub code spaces, but then using GitHub deployment where you can apply your policies in a consistent way. And so the goal really, and the ask, I suppose, of you guys and everyone else is if those start to make a lot of sense in how you get started and some of the best practices Microsoft is providing, if you start using those, you can contribute your own scenarios and solutions there, and then we'll be able to build up kind of this ecosystem around best practices, around samples, not just on how they work, but actually having people be able to fork the code and get started and use those as templates for building their own applications. Okay, so with that, I will spend the last few minutes on Q&A. Hopefully you got a view into what we're providing with functions, all the latest announcements we just did at Build, but also some of our focus over the next few months in kind of moving these things from public preview into GA, and also working on a bunch of other capabilities around inner loop, outer loop, and new language support. So let me see here if there's any questions. I'll start up here. So the first one's from Richard, which is, what's your take on the future of cloud-native computation applications using microservices and other loosely coupled designs? European markets, given the new extensions of data protection regulations and initiatives on where data can be processed in an unencrypted state. Yeah, so I think this is a lot of, that's a great question, Richard, and probably can't be answered real quickly in a minute, but one of the goals of, we don't just see it in European markets, but across the world where there are these governmental requirements to keep your data, sovereign inside of your own country. And so bringing not just the application services into Arc, but also our data services, you probably saw over the last year got announced as well. This kind of allows you now to keep all of your data and compute local inside of your own country's requirements and never have that data leave. So hopefully it opens up a whole set of scenarios from that perspective as well. So you can still take advantage of microservices on PaaS, but you don't have to be restricted depending on where it needs to be hosted. And can we make monitoring tools for durable functions like the tracing and monitoring like logic apps, for example? Yeah, so Durable has monitoring already. So it has native integration with application insights. So you should be able to see, very similar capabilities you have with logic apps with application map, with all of the logging. If there are specific things that aren't available through application insights, please provide feedback, either through the forums is always a good way to provide feedback. If the documentation isn't good, add feedback there, or even on our open source functions is also a place you could ask questions. The other one I see is, does the premium tier scale up and down automatically? Yes, it does. So that's one of the benefits of premium is that it does require one instance to be running. So there's always one instance needed, and that's for the cold start capabilities, as well as some of the networking requirements, but you still gain all the benefits of traditional serverless capabilities in that as you throw a bunch of work that needs to be processed at it, it will scale up to as many instances as are needed to process those. And then once all of those messages or data has been processed, it will scale back down to that one again. So you still get all the benefits of serverless and dynamic scaling inside of Premium. And one of the last questions I see here is who do you pay for Arc? And so that's a good question. So for public preview, there's no charge for application services during the public preview as it is today. We will be announcing pricing as we get closer to general availability. But in general, you kind of pay for the services you use, a very similar model. If you look across how Azure Data Services work on Arc and how management services work with servers on Arc, is the idea is that you'll pay for what you use. And then I see one last question, which is, now being able to run logic apps and functions anywhere, where does that leave the use of integration services environment, ISE, and application environments, ACE? Are those even relevant anymore? Well, they're definitely still relevant. I mean, there's, we had a slide earlier on around this kind of control requirements up until productivity, and this kind of sliding scale between, why you might need more control over your environment all the way up through where you need less. And so in some ways, you could think of ACE kind of fits between that Kubernetes environment and the pure PaaS serverless environments. Because it's still a managed environment for you. So it still does a lot of things in the back end that you would have to do yourself if you're running on top of Kubernetes. And so there's still lots of benefits of taking advantage of ACE because there is less management involved, but they do offer similar capabilities in that they do give you a lot more control over the underlying infrastructure. But they still are complementary. It's just another capability inside of there. Although the Kubernetes is mostly designed, obviously, for customers who want to run on premises, but obviously it does work inside of AKS as well. I see one more coming in from Jeffrey. Follow up on my previous question about monitoring tools for durable functions. Logic has a more visual overview and visual management capability. This would be very welcome for durable functions as well. Thanks, Jeffrey, for that follow-up. Yeah, that's definitely something I'll follow up with the team and try to take a good look at, because I know Logic Apps, those guys do such an awesome job making sure that you can easily understand, not just when you're building your Logic Apps, but also how to monitor it. I know Functions does have capabilities there, but Durable, I'll take another look at and just make sure you're asking for so that you can kind of understand how these orchestrations, activity functions are tied together. Okay, so with that, I think that's all the questions.
Covey.co